Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're going to see problem maximum sum of three non-overlapping subarrays. Now, unlike others, I will simply not just tell you the corresponding DP solution and just say, okay, this is the corresponding answer. I'll make you go through the actual stuff and also the most optimized stuff. Now again, sorry for the video being a bit late. It took around 2.5 hours to make this entire notes. So yeah, let's start off. It simply says that you are given an integer array nums and an integer k, right? And basically you have three non-overlapping subarrays of length k. You have to find three non-overlapping subarrays. Non-overlapping, which means, okay, let's say a subarray is continuous set of elements. Size should be k, length should be k. It's just that these three should not be overlapping. As you can see, these three are not overlapping. While in this case, if I take this one, this is overlapping. I cannot take overlapping subarrays. That's the actual crux of the question. And ultimately, we have to return a list of indices corresponding to the starting position of each interval, right? So let's say if I take these three as my three subarrays, so index is 0, 1, 2, 3, 4, 5, 6, 7. So index is 0, 3, 6. That is my corresponding answer. Cool. So you just have to tell the one which is having the lexicographically smallest index. Why it is required? Because if you see very carefully in this specific example, I can have one such configuration look like this, right? Its index is 2, as you can see, sorry, 0, 1, 2, 3, 4, 5, 6, 7. Its index is 1, 4 and 6. While if I take this specific configuration, then its index is 0, 4, 6, which is lexicographically smaller. If you don't know, then simply if I give you these two indexes, right, 3, 7, 8, 3, 7, 10 and 2, 8, 12. So we'll start comparing by first, okay, whichever is lesser, that will be lexicographically smaller. So this is lexicographically smaller. Okay, let's say if I give you these two, then what? As you can see, these two are same. Okay, move on. These two are same. No, not same. It is lesser. So it is lexicographically smaller. Okay, let's say if I give you these two, then these two are same. These two are same. Oh, this is lesser. Oh, if this is lesser, answer is this one. This is lexicographically smaller. So this is how you find which will be the lexicographically smallest list of elements, or you can say a vector of integers. Cool. Now, ultimately, did you see very basic ultimate stuff which is required in this? Ultimately, there are two things from where you can start off your answer. If you want to start off with the corresponding DP approach, I would have just told you that, okay, you have to find three non-overlapping subarrays, which means you have option to choose three starting indexes, right? Okay, if I can choose this as I, next one can be j, next one can be k. So that from that I itself I can start off with the corresponding DP intuition. But obviously that again, if you want to, you can try it, but the video will become way too long. But I want to make you sure, okay, like you actually are encountering actually like optimal solution also. So I will let you go through by seeing that you have to find what ultimately for any subarray, your ultimate maqsad as an aim is to find the maximum sum. Now if I ask you what is the best strategy to find the maximum sum possible, right, or I should say rather maximum sum, leave maximum sum, let's take only the subarray sum, because obviously you have to take a subarray and take the sum of it. Maximizing is a later part, but sum and subarray, if I want to find what is the best possible strategy I could have, obviously I can take the prefix sum technique. No matter what, I can use this also in the corresponding DP approach if I would have taken it. But okay, that is my ultimate thing which I realized, that I can find my subarray sum, and again the size is also fixed, so that is also one thing. But any subarray sum I can find very easily by the prefix sum technique. Now for the folks who don't know what prefix sum is, simply go and watch this 4-minute video, you will get the answer. So there is one thing, okay, prefix sum can find the subarray sum of any size, but there's a catch. You have this specific length k which is fixed. So length k, which means size k of length, is fixed, which means that can you use this? Maybe, maybe not. But right now, okay, I can use prefix sum to find the subarray sum, and that is more than sufficient for me. Remember this fact. I told you that there is a actual extra stuff which will help us to optimize it later on. But okay, I told you. Now, ultimately, we realize that we have this specific nums. We know that this is a specific nums. We know that we have to take something of the sort that, okay, some left subarray, right? Let me change the color. Let me have it by, okay, last time people were saying not to have green, so I will take pink. Pink I have already taken, so let's take white. So ultimately we saw that, okay, we can have one subarray in the left, one will be in the middle. Again, right now it can be here also, anywhere, and then one will be in the right. Again, right one also can be here also, like not necessarily here. So one thing we realize that, again, as I told you, that these can be multiple configurations, that, but in general the fact will be one in the left, one in the mid, one in the right. Now ultimately your maqsad was to find the maximum sum. So if you want to find the maximum sum, and also you cannot try for all three subarrays, which means, let's say if I take this as a corresponding start index, then to take the middle subarray I would have to go to all the possible middle indexes. Then for any possible middle index j, I have to go to all the possible end indexes k. That will ultimately be a O of n cube solution, which is obviously not good. So how I can do it? Simply, let's see that if I would have taken any specific middle, again, let's focus on that, how I can get my answer in O of n time, which means earlier I was trying for three possible subarrays. Now let's focus on if I only want, or I can only iterate on one possible subarray. Now you might ask, Aryan, how did I know that I have to focus on middle one only? Because simply see, if you focus on the left one, then you will still have to figure out about about middle and right one. If you focus on the right one, then you have to figure out the things for left and middle one. But if you focus on middle one, then ultimately automatically I can do some computation such that these two, because see, obviously these two can be similar in fashion, so I can somehow do some computation for them such that I don't have to run a loop specifically for these two. Okay, let's see now how we can do it. So if we have, let's say, any specific subarray, ultimately my aim is that in the left side I should be able to, obviously I will be iterating, as I mentioned, I will take O of n time to try for all possible subarrays in between. And again, to find the sum of any possible subarray at an index I know it is very easy. Simply go to I plus k minus 1. As you can see, I is 3, I plus k will be 5. But to find the subarray sum from this to this, I take this element of my prefix sum and subtract it with this element of my prefix sum. So I will take prefix sum of I plus k minus 1, subtract it with prefix sum of I minus 1. Thus I will simply get my summation of middle subarray starting off with index I. Okay, that is sorted. So that is sorted. I can easily find it in O of 1 time. So I can, which means I can also iterate on every possible middle index and can also find its sum in O of 1 time. So middle index or middle subarray iteration can be done. But the catch here is, how can I leverage, or how can I do some computation for the left and the right? Let's see for the left first. So for the left, ultimately what my maqsad is, if right now I forget about the indexes, which is my actual maqsad, ultimately the index also is only and only when, again, indexes will be used only and only when I have to find the corresponding maximum sum. That's my ultimate maqsad, maximum sum. So for now, let's forget about the indexes. Let's only remember that, okay, we have to get the maximum sum. So I will take prefix maximum subarray sum, prefix maximum, which means that, okay, for this specific subarray the sum is 3. For this specific subarray the sum is 3. Again, how I can find it? By using my prefix sum array. 4 minus 1 will be 3, 6 minus 3 will be 3, 12 minus 4 will be 8, 19 minus 6 will be 13, 24 minus 12 will be 12, and 25 minus 19 will be 6. Now what I got from this? I got that for every possible these things I got my answer. But again, I wanted that, Aryan, before this point, any subarray of size k, give me the one which has the maximum possible sum. So ultimately simply maximize this thing, which means take the maximum. Okay, 3, 3, 3, it will be 8. Okay, it will be 13, it will be 13, it will be 13. So I just took one thing. Firstly, I found the individual subarrays. Then I took the prefix maximum of them. Why I took the prefix maximum? Because I want that if I am standing at this index I, if I look back and ask my prefix max subarray sum, then he will tell me that up till this specific index, whatever is the maximum sum subarray, whose sum is maximum. Okay, then which means ultimately if you have to find out how I computed this value, again as I told you that I can simply compute it by taking, if I am at a specific index I, let's say if I am at specific index I, okay, if I just simply remove it, yeah, index I. So this is my corresponding sum, right? This is my corresponding sum. It is nothing but, if this is the corresponding index I, it is nothing but prefix sum of I minus prefix sum of I minus k, because this value will be I minus k. Now, the based on how you implement it, the implementation will change a bit, because if you see that my implementation will involve, as you know, a simple prefix sum technique. How we build this specific array, we build it by saying prefix sum of I will be nothing but prefix sum of I minus 1 plus nums of I. This is what we do. That prefix sum of I is nothing but prefix sum of I minus 1 plus nums of I. But if you see that there is always a 0 which we put off, which we start off, right? Thus, what we do in general is we shift our prefix sum array. Again, it is totally up to it is totally up to you that how you implement it. But usually what we can do is that we can have a condition that, okay, if the index goes, because see, if I ask you what is the range sum of this, then you might say, Aryan, the range sum of this is that prefix sum of I minus prefix sum of this thing, index of minus 1. But that is not there. So how will you find it? That is the reason, to avoid these kind of situations, we right shift this prefix sum by 1, which means that prefix sum of I is nothing but prefix sum of I minus 1 plus nums of I minus 1. Now why it is nums of I minus 1? Because I have shifted thing by 1 on the right side. So you will also see that the same thing I will do. Now whenever in future I have to find the actual prefix sum, because I am ultimately iterating on the input array nums. So if input array is nums, I know that my prefix sum is shifted right side by 1. So always make sure to shift it right side by 1. So in the existing stuff, again, it can be a bit confusing if you have not seen this kind of strategy before. But okay, it's good to actually try run this by yourself also. But I'll not focus on this much because it is not the prime thing in this question. So as you can see, I simply shifted it by 1 plus 1, I plus 1, I plus 1. Cool. Now, as I told you that, okay, we were able to find middle. Again, we are ultimately iterating on the middle subarray. We are able to find the left in by doing some pre-computation, left subarray sum maximum by doing some pre-computation, and the same we can do some pre-computation for the right one also, because that's also what I have to find. Again, to compute this specific subarray sum from the right side, I can simply take that for this specific subarray, if the index is I, obviously I can take that the prefix sum of this value, which is I plus k minus 1, I plus k minus 1 is this specific value, minus prefix sum of I minus 1, which is this value. So this minus this will give me the subarray sum from here to here, right? Subarray sum from here to here, which is 12. So again, did the same thing, but I told you that I have shifted one side right. So do a I plus 1, I plus 1. So this will change to prefix sum of I plus k and minus prefix sum of I. Again, I am showing this because I'll show you in the code. So as to not confuse you, I am showing it right now only. Now, I have done the pre-computation for the right, I have done the pre-computation for the left. Simply get the answer now. So I will simply iterate on the middle. I'll simply iterate on the middle subarray. And when I say iterate, I will simply iterate on the index of the starting position of the middle subarray. Now, obviously, I know it should be non-overlapping. So the starting position of the middle subarray should start from here. And obviously, end can be here at this index. So what is this index? This index is k. What is this index? This index is from the very last, take 1k, take another k, which means n minus 2k. So I will simply start my iteration for the middle subarray starting from this index to this index. Now, as I start from this index, I know what will be the sum for it. If I is here, I can easily find the sum, as I told you earlier also. I have also done the pre-computation for left maximum, as you can see, and I have also done the pre-computation for the right maximum. Simply at any index, go, if I just show you, for any index, go and look, sorry, yeah, for any index, go and look for your left, which is this. Okay, 3. 3 is the sum. I know the current sum is 8. 3 is the left maximum sum. And if I go and look at the right, 12 is the right maximum sum. So 12 is the right maximum sum, 8 is my sum, 3 is the left maximum sum. So if my middle index, or I should say my middle subarray, is actually at this index, then this is the maximum possible sum I can achieve. And thus I can same try for all possible indexes. Now, this is what you did, but it was pretty awesome, pretty good. But you ultimately had to find indexes, not the summation. If you remember and go back, your ultimate maqsad was to find the list of indexes, not the list of summations. So here, if you look back, okay, where it is gone? Yeah, you were actually finding summation. You found the actual maximum summation of the indexes. So ultimately, don't change anything. Just maintain, rather than maintaining the actual sum, simply maintain which index actually gave me this specific sum. So I will simply maintain the actual index who gave me this specific sum. And again, it will be pretty simple, as you can simply see that if my I, again, I can be anywhere whatsoever, but your specific, again, like if I just simply mention any specific I, so I can simply change that whoever changed that specific left sum, and same way I can maintain whoever changed that specific right sum. If I show you the code, it's exactly same. I will maintain left max index. Now when I say max index, it ultimately means left maximum value whichever index gave me, first index which gave me the maximum value iterating from the left side. This is what it actually means. Now if it actually means this, then firstly I will start off by saying current left maximum sum. If I start off by simply taking the prefix sum of k minus prefix sum of 0. Now you might ask, Aryan, the first subarray sum is nothing but prefix sum of k minus 1 minus prefix sum of minus 1. But yeah, I told you that I will add a plus 1 every time. So I do like this. So this is my first subarray sum. Now I will simply start iterating from, if I just simply erase this, I will simply start iterating from here, which is I is equals to k. Right, again, just to build this specific subarray which I built before also. It's just the only change here is I am now incorporating indexes rather than actual values. So as you can simply see, I will find the current sum, which is the same range sum. Is the only change here is that if my current sum is more than my maximum, only then I will update my index, right? Only then I'll update my index. Now as I told you that if, let's say, for this specific thing, obviously you are iterating from the left side. So if your index is here, if your index is here, again, I don't want to confuse you, but let's say if your index is here, then you did a prefix sum of left by taking this specific thing, like this specific thing. I is here. You want to maintain the first index of this specific subarray. What is the index? The index is the starting point of this specific subarray. I know the length is k of that specific subarray. I am at index I. So what is the actual start index of this specific subarray? It will be I minus k. I minus k will become 0, do a plus 1. That is the reason I have written that the actual index, obviously, this was the sum of that specific subarray whose index ended at I, but I want to maintain the corresponding start index. That is the reason I simply took I minus k plus 1. So as you can see, I minus k plus 1. And again, if the current sum did not change, simply keep it as is. Now, the same thing I will also do it for my right movement. And as you can see here, as I was moving from right, so for this index I was taking this as a sum. So obviously it is already a start index of my specific subarray. So I can simply say that for right, I can maintain my index I itself as the start index, right? And again, the same logic as what we saw for left side. Now, when this is done, ultimately we are pretty good. We know that we have to iterate for our middle subarray start index from k to n minus 2 into k. Then for any specific index, I will firstly find and go to my array and get me this specific index. What is this? This value is nothing but the index itself. So my left index will actually become this specific array, which I named as left max index array I minus 1. As you can see, I minus 1, this is index I minus 1, I and then minus 1, I minus 1. This will give me this value, which is 0. Again, what is this value? This is actually the left subarray start index value. And same way, I can go on the right side. If I go on the right side, which is I plus, I do I plus k. So it will be I plus k on the right index, like right max index array, right max index array, I plus k value, I plus k value will give me the right index, which is the start index of the right subarray. I know the middle, I know the start index of the middle subarray, I know the left index, I know the start index of the left subarray, I know the start index of the right subarray. With that in hand, I know the left index of the I know the start index of the left subarray, I know the start index of the right subarray, I know the start index of the middle subarray. In that case, simply use your prefix sum again and find the range sum from this index to this index plus k minus 1 to just get, again, to just get what? To get the range sum of the left subarray to get the range sum of the right subarray, right? Ultimately, this is the corresponding code. I firstly find the left with this what this left indicates. This is the start index of the left subarray. This is the start index of the right subarray. This is my current sum, which will be middle subarray sum, left subarray sum, right subarray sum. If that current sum is exceeding my maximum sum, which I am maintaining, I'm maintaining above, then I can simply maximize my maximum sum, and I'll also maximize my result. Or I should say, I'll only change my result whenever my sum updates. And every time I'm only maintaining the leftmost indexes every time. Now, if you would have skimmed it, then you must have seen that here the thing is more than or equal to. But if you see and look here, it is only more than. Can you comment why it is more than equal to? Because if you remember, this portion, right max index, it is when I'm iterating from the right side. If I'm iterating from the right side, then if this has a sum of 6, if I found another subarray having the same sum of 6, I should still modify my index because I want the least possible index. And least possible index is the index which is, lesser. Much lesser index is actually much preferred because I want to maintain that lexicographical order. So for lexicographical stuff, I should always keep on, if I go back, okay, where it is gone. Yeah, I should always make sure that I should always maintain as small index as possible. With this strategy, it will always maintain the smallest index. Now, again, if I just show you the combined code once quickly, then firstly, I maintain the corresponding prefix sum. Again, make sure this is one right shifted, as you can see, right shifted by 1. That is the reason everywhere in the code, wherever I'm using prefix sum, I will do a +1 to shift that by 1. Here, as I told in the code also, explanation also in the diagram also, I showed that this is how we will maintain the starting index of the maximum, giving the maximum value for the left subarrays. This is the same starting index giving the maximum value for the right subarrays. And again, ultimately, when I have got all these, I will simply start my iteration of the specific result. And again, ultimately, just saying that get me the left, get me the right, and get me the corresponding current sum. This is the left. This is the starting index of the left subarray, starting index of the right subarray, ultimately getting the current sum. If it is maximizing, just update the result and get the result itself. Now, ultimately, you know that you are simply iterating on this input array many times. So time is O of n, space is also O of n. The catch is, can you improve it? Maybe yes, maybe not. But still, that's a very good job that you have done it and got the corresponding answer. But can you improve it? Yeah, obviously we can, because if we look at very carefully, I showed you in the very beginning also, my size of subarray is fixed. When I say fixed, I was using a prefix sum. Right? I was using prefix sum. Now prefix sum is used for any size. I can find the subarray sum of any size in O of one time by using prefix sum. But if I have a fixed size, I can use another technique which is called as sliding window. So if I know this sum as 3, I am just sliding my window of size k. I can just incorporate this incoming element and will just simply remove this outgoing element. So by using sliding window, I can find subarray sum, right, of range of size k in just O of one time as I move forward. So let's say I got the answer for this sum, which is 3. As I move forward, I will simply plus 1 minus 1. It becomes 3 again. As I move forward, plus 3, which is 6, minus 2, which is 4. Okay, this become 4. As I move forward, plus 2, which is 6, minus 1, which is 5. So this became 5. So you see that with using a sliding window approach, I can solve it. Now, how I can leverage it? Let's see. Again, it's a bit tricky to actually think of it, but yeah, this will come by more of visualizing and understanding and maybe playing around with the problem itself. That how we can leverage this fact. So how we can leverage this is by saying that in the very beginning, I know I have to use a sliding window, but now I have three possible subarrays. First one is this one, second one is this one, third one is this one. Ultimately, remember the maqsad. Maqsad was to get the maximum sum, but not exactly. Maqsad ultimately was to get the best start indexes. So ultimately, you should maintain the best start indexes. So like BS1 indicates best start index. Now you might say, Aryan, what is this 0, k? What is this? Okay, no worries, forget this. But if you remember one thing very carefully, I ultimately in the above approach also, I started off by saying that let's forget about indexes. Let's only focus on maximizing the sum. Then probably later on we can come on to indexes back. So I will maintain the current sum, current sum, current sum, right? And thus I will also maintain what should be the corresponding maximum sum. If you remember, maximum sum. What is the maximum sum? Maximum sum is the sum of all three values. Sum of all three values, which is, let's say, in the beginning 19. Now you might say, Aryan, why did you maintain this? Okay, we'll come on to it later on. But you realize, okay, I will maintain the current sum, I will maintain the maximum sum, and then I'll use simply sliding window. How I will use it? I know I have three subarrays of equal size k. Then my starting index, starting from 0, it can go up till what value? Obviously, the last one will be 3 into k. To incorporate three such subarrays. So it will go up to this index, which makes us sure that okay, I'm incorporating 3k elements in the last. What it is? It will be nothing but n minus 3k as an index. So for my first subarray, I will start off from index 0 up to index n minus 3k. Okay, this is my actual iteration which I will do. What I mean by iteration? Iteration is okay, as we in the very beginning saw that my three subarrays looked like this. I know I have to slide my window, which means now my first window will move. If my first window moves, it will become like this. But now you might start asking, Aryan, isn't it wrong? Because technically you are moving your every window adjacent to each other, which is technically wrong and it should not be there. Yeah, obviously it should not be there. And yeah, because of that reason only, we have to maintain for individual thing. Okay, if I only would have taken this, then what would have been the maximum subarray? Because that I can leverage. If I take for the first subarray, what can be the maximum subarray? I can leverage that specific maximum number by giving it to second subarray and saying that okay bro, you take your current sum, take the maximum from the left and try to get that you both together how much you can produce the maximum subarray. And the same thing, by you both together, whatever you can produce maximum, just give it to the third one, which is the right side, and ask him what you all three can produce, like you all three can produce together. So that is the reason we took up that maximum sum 1 by taking only the current sum 1, maximum sum 2, which ultimately will take in leverage. Again, in the very beginning, it will take in leverage the current sum 1 and the current sum 2, but later on in future, it will take in leverage maximum sum 1 and current sum 2. And same way for maximum sum 3, it will take in leverage right now in the beginning, it will take in leverage all three sums just to initialize it. But in future, it will take maximum sum 2 plus current sum 3. Cool. Let's see how we'll do it. Firstly, we realize that individual current sum we can find by using sliding window. How I will use it? Obviously, as I told you that how we do a sliding window approach, we take this specific current sum which we got in the last step. I know that my index is I. I have to add this specific element, remove this specific element. If my I is this, what is this specific element? I told you earlier also, if I is this, k is the window size. So I plus k minus 1 is the specific element. I am removing what? I minus 1. So in the existing current sum, I will add nums of I plus k minus 1 and I will subtract nums of I minus 1. It is nothing but a sliding window of current sum. And the same way I will slide current sum 2 and current sum 3. So now I got current sum 1, current sum 2, current sum 3. If I've got current sum 1, current sum 2, current sum 3, but my ultimate maqsad was to get the maximum sum. To get the maximum sum, again, I just showcase the actual values also. Here it is 3, 3, 3, 13, and here I will get 3. After that, I will get 8, I will get 12. I told you that firstly, I want to get the maximum sum for this thing, current sum 1. So maximum sum is 3. Here is also 3. Okay, it's okay. Then I will go on to current sum 2. Sorry, I have to find the maximum sum for 2 subarrays here, which will take in leverage the maximum sum for one subarray and then the current sum of the second subarray. So maximum sum so far, we realize it was, again, let's take maximum sum, ms. ms1 so far was 3. ms1 so far was 3. To get the maximum sum for 2, I will take whatever maximum sum I have got up till 3. Again, it could have reduced also. It could have reduced also, but I am only concerned about maximum sum. So maximum sum up till this index and then the current sum if I am getting, which is nothing but the current value, which is 8. Now you want to say, Aryan, are you blindly updating it? No, I will not. I will have a simple if condition. What is the if condition? If the maximum sum 1 plus current sum of 2, if it is more than my maximum sum of 2, only then update this maximum sum of 2, right? So I will simply say in this case, in the previous case, if I remember, my maximum sum was nothing but, maximum sum 2 was nothing but 6. But now because of coming of 8, let's bring it back, 8, it actually become 11. So I'll update that and say it as 11. And same way, because now I want to leverage this also, and because again, why I am leveraging max sum 2 for max sum 3? Because obviously for max sum 3, it is possible that it can be bifurcated, which means, okay, one array here, one array here. So for my second array, I am leveraging the fact that the first array can be anywhere in the beginning. For my second, or I should say for my second subarray, I am leveraging the fact that I can have anywhere my first subarray anywhere in the beginning. To leverage the maximum for my third subarray, I am leveraging the fact that these two can be also anywhere, which means that the second subarray, not necessarily it is here, it can be possible that here also, maybe it is giving the maximum answer here. And when I was computing the maximum for this, I was considering that the first one can be also anywhere. That is the reason I took to find that the max sum of 3 will be nothing but max sum of 2 plus the current sum of 3, right? And thus again, I will also have the if condition for it. Now you might say, Aryan, this is okay, but still you're computing the sum, but you have to find the indexes. Okay, no worries. That is the reason if I show you that if I go back, I told you that for max sum, I'm maintaining only current sum. For max sum 2, I'm maintaining the max sum. I'm maintaining the 3 possible sums. For max sum of 3, I'm also maintaining 3 possible sums. Technically, I will override by saying max sum of 2 plus current sum of 3. But this max sum of 2 is also built up of max sum of 1 plus current sum of 2. And this max sum of 1 is built of current sum of 1. Or I should say current sum. So technically, to actually maintain the indexes, I have to maintain 3 indexes on the last step. Which 3 indexes gave that specific maximum of 3? At this step, I will maintain two indexes. At this step, I'll maintain only one index, right? So as you saw that this is nothing but maximum of 2 plus current sum. So these three indexes, again, if I am overriding maximum sum 3 by a higher value, and the higher value can be only maximum of 2 plus current sum of 3. So I will update these two with these two indexes of maximum of 2, and the third one index will be of current sum of 3. Same way, when I'm updating my max sum of 2, I will update the first index with the max sum of 1, and the second index will be the current sum of 2. So if I show you the same thing, I initially had my best start index 1 is nothing but 0. Here I had for best start index of 2, but I told you I will maintain two indexes. One is the 0 here and another is the 2. Another is the 2. For best start index of 3, I will maintain 0, 2. As you can see, 0, 2 here and then the 4. Then the 4. Now, as you know, I maximized it. So, as current sum of 1, I should say the max sum of 1, it did not maximize. It still remained 3. Here also 3. So, BS1 also stayed remain the same. For BS2, as you realize that max sum, like it actually maximized, it became 11. So I will update by saying that whatever get me from BS1, okay, this one, and the current index, if you remember, this was the current index, which was 3. I updated that 3. And the same way for BS3, I will simply say that for BS3, get me the two indexes from above and then the current index, which is 5. And thus you see that I am also maintaining. And again, if I ask you, what are the three indexes? Which is my answer? These are the three indexes which is my answer. So this is how I can maintain three best indexes by maintaining their three best maximum sums. Cool. Again, if I just show you the glimpse of this specific piece of snippet, it is something similar which I showed you. Maximizing the max MS1, maximizing the MS2, maximizing the MS3. And as I showed you, if I maximize it, then okay, it will become maximum. Update the best start index 1. Update the maximum by current sum of 2 plus max sum of 1. And update the best start index by taking best start index of 1 and the current index of 2. And same way, max sum of 3 will be current sum of 3 plus max sum of 2. And also maximizing the best start index of, by taking these two values. If I just simply erase this, these two values and the current sum of I. Now, if you are just thinking of Aryan, how did you reach to these index values? Just a quick glance. As I told you, I was iterating on my I. So if you remember, my I is still here. So you have to find all these indexes, which means if you remember, currently this index I plus k is the second subarray start index. This is the third subarray start index. So it is I plus k. It is I plus 2k. So that represents second and third subarray start index. It is the current subarray start index. Cool. Let's see the code again. It is actually hard. That is the reason no one discusses it. Like no one discuss this everything again. I highly recommend. If you think it was a bit hard, just go and watch the video again. Actually, it is hard. That is the reason you will see no one. I repeat, I bet no one will discuss this on YouTube. And that's the reason I want to discuss this, because no one discuss it. Let's see the code. It's simply very simple. I firstly maintain the best start index, then the current sum, max sum, max sum, max sum 1 2 3, current sum 1 2 3, best start index 1. But best and then best start index 2, which is best start index 1 and the current start index of second subarray. Same way, best start index 3 will be nothing but these two values from my best start index of 2 and the current start index of the third subarray. Let's start off by simply building up your first. I will firstly initialize my current sum 1, current sum 2, current sum 2, current sum 3. This is nothing but, as I told you in the very beginning, initializing my current sum 1, current sum 2, current sum 3 for the starting values. And because I initialized my BS1, BS2 and BS3, that is the reason I also initialize the corresponding current sum values. And ultimately, updating the corresponding maximum sum also with the same values. Cool. Now, if I go on and start my iteration, it is the exact same code. as I have already considered the 0 index when I was initializing, I should start off my iteration from the actual index. Wait, it's gone. Okay, yeah, I'll start off from my actual index 1 because I've already considered my index 0 earlier, right? If I go into index 1, I told you that it will go on from index 1 to n minus 3 into k. If I show you where it is gone, okay, I told you, I remember. It will go, yeah, this, it will go from, like, actually, again, 0 I have already covered, so it's the reason I start from 1, but I will go on from 0 to n minus 3k, 0 covered, so it will go from 1 to 3k, sorry, n minus 3k. Again, I will simply update my current sum by using sliding window approach. I got the current sum, and this is the exact same thing which I told, that maximizing the maximum 1, maximum 2, and the maximum 3, and also updating the corresponding best start index, their best start indexes. And ultimately this maintain best start index 3 maintains all 3 possible best start indexes. That is my corresponding answer. Thus, as you can simply see, I used these two vectors, which is of size 2 and 3, and I did not use any extra space at all, just a few variables. That is the reason my space is O of 1 and time is O of n. Cool. I hope you guys got it. If yes, then do smash the like button. If not, I highly recommend. It is not easy. It's actually pretty hard. Again, especially to go through the O of 1 approach. And again, there can be chances that O of n approach also people usually find, memorization easy, but this is actually, again, you can say it can be a DP problem, but obviously I want to make sure that I am explaining you something which is intuitive and also at the same point can help you much more in your different contests. Especially these kind of problems are pretty much very common in code forces contest. So yeah, that will be very much helpful, and arrays is also very important. Now if you liked it, then smash the button. Bye bye, take care.